So we would like to solve this equation with a trig function in it. And if your original equation has sine, cosine, or tangent, that's good. But if it doesn't have sine, cosine, or tangent, you need to turn it into one of those three. And the big picture, how you're doing that, is once you get your trig function by itself, the reciprocal of secant is cosine. So secants turn into cosine. The reciprocal of cosecant is sine, so cosecants get turned into sine. And then cotangent's reciprocal is tangent, so any cotangent gets turned into tangent. So this particular one, we're going to be able to turn secant into its reciprocal cosine. And since they're reciprocal functions, it just means their answers are reciprocal. So the reciprocal of this number is 1 over that number. I'm going to go ahead and do this division. 1 divided by negative 2.3144. Something to be careful of. I know it's really annoying, but you want to write down the entire set of decimals because you don't want to ever reuse a rounded number. Granted, your calculator is rounding clear out here, but you want to write as much as possible if you're going to reuse a number. Okay, then from here, we're going to sketch a picture of what's going on because that's going to be key in us figuring out the answers. But the main idea of what this is saying, on a unit circle, all points come in cosine of theta comma sine of theta. So the answer to every cosine of theta is your x coordinate. So we want to look on the unit circle for where there would be some points that have x coordinates of approximately negative 0.4. To do that, I'm going to sketch a picture of where that's happening. Okay, so let's picture that. If you have an x coordinate of negative 0.4, you're going to have to go back, and to go all the way here is a distance of 1. So this is a distance of negative 1. That would be negative 0.5. So if I want to only go back negative 0.4, it's going to be a very small amount. Now, if you're not sure about that, what we can do is compare it to a point we already know. Okay, on our unit circle, we have these 3 main points, and the x coordinate of this one, this is negative 1/2 comma root 3 over 2. So I can go negative 1 divided by 2 and get negative 0.5. I divided the top and bottom to get this, but frankly, I only care about the x coordinate because I'm trying to make a sketch of a point on the unit circle where the x coordinate is negative 0.4. So it's not back as far as this one. So it's going to be back a little bit less. So I just made that gray dot. And so that is one of the places where we have a point on the unit circle with that x coordinate. And then similarly, if I go back that amount and up, I should be able to do the same here. So a second place that we would end up with an x coordinate of about negative 0.4 is right there. To solve this original equation, just to back up for a second, we're looking for what angle measures give us this x coordinate. So I'm going to come back to my original here. I flipped this over and I have cosine. Now I'm going to go ahead and use my calculator to solve that. And to get theta by itself, I'm going to inverse cosine both sides. And inverse cosining both sides, I end up with 2.01, etc. Okay, so this angle measure is my theta. And keep in mind, this is the angle where the x coordinate is negative 0.4. So let's go put that on our picture. This is 0, angle measure 0. This is pi divided by 2, that's 1.57. And we want 2 point something. This right here is pi, so that's an angle of 3.14. So what just happened, what that told us, is that point, the theta, is what is the angle that goes with that x coordinate. And that angle measure is that we found. Okay, but we need to use this information to help us figure out what is the angle here. So what I could do is, if I could figure out what that little mini angle is right there that I'm calling beta, if I can figure that out, then the angle that goes all the way to here is 2 pi over 2 minus that little bit is going to be all the way to that. So I'm going to say, well, beta is pi over 2 subtracted from my bigger angle theta, and I grab my calculator and I put in that hideous decimal minus pi over 2, and I end up getting this beast here. Okay, so now I know that little angle measure, so I'm going to use that to figure out what it is to get all the way around to this other point that has an x coordinate of negative 0.04. Okay, so let's do that. So I'm going to get this guy, if all the way to here is 3 pi over 2, I just need to subtract that little bit from it. So I'm going to take the 3 pi over 2 minus this big long decimal here, and I find out that alpha is this angle here. So these two are my theta, and this guy right here, those are my final answers. I'm not going to do one of every kind. I'm going to do a tangent in a moment, but just remember that if this would have been, instead of secant, let's say it was cosecant, you would have gone from cosecant to sine by flipping this over. And then what would be different is sine is the y coordinate, and so I would be trying to draw a picture with a y coordinate that is the number there. Okay, so then let's do one here with cotangent. All right, so cotangent, every time you don't see sine, cosine, or tangent, you force that to happen. So the reciprocal of cotangent is tangent. So I'm going to turn that into tangent by taking the reciprocal of that fraction. Now, negative 2/3 is fine for most of you, but I went ahead and divided just to make sure that the decimal was in your mind. That's negative 0.6 repeating, and I need to use that to make a sketch. Normally, when we find tangent, we take the y coordinate and divide it by the x coordinate. So we want the angle measures where the y coordinate divided by the x coordinate is negative 0.6, but it's really time consuming to sketch that. So if you remember that tangent is really slope, my sketch is going to be what angle measures give me a slope of negative 0.6 repeating. Okay, so I'm going to look for angles where the slope is negative 0.6. So let's start off with a picture of my unit circle. I already have kind of a lot of stuff here. Sorry, but keep in mind, a line like this, a slope of 0, that's the tangent. Oh, sorry. Okay, sorry. The slope of this line is 0. The slope of this line is 1. The slope of this line is undefined. The slope of this one is negative 1, because we're going downhill, and so forth. So if we want to draw in the one that has a slope of negative 0.6, first off, lines that when your eyes hit them go up have a slope that's positive. So that can't be in quadrant 1 or in quadrant 3. If the slope is negative, it's got to be in 2 or 4. And then you know how when a line, if it's steeper, Like if this is a slope of -1, that'd be a slope of -2, -4, -10, -100. Okay, if I go this way, it's a slope -1/2, -1/4. So -0.6 repeating, it's going to be a line that is less steep than -1. And so it's going to be, and I just made it approximately here. So this is the first point, this guy right here, this angle from here to here, and I call that alpha. This angle right here is one of the angle measures that gives me a slope of -0.6 repeating. So this angle is one of our answers. Now if you extend this one out, this line right here also has a slope. It's going downhill. Right here, this is a slope of -1. Less steep is here. So this is another place where the slope is -0.6 repeating. This was -1, less steep, -0.6. So these are my two approximations. So ultimately my final answer is going to be, what is this angle alpha? And also, what is this angle beta? So to figure that out, I need to go back and use the equation and solve it. So I'm going to come up here. There's my original that I got to. To solve this for theta, I'm going to inverse tangent both sides. And when I inverse tangent, again, I don't want to use a rounded number, so I did not just do inverse tangent of 0.6. I filled the screen with 66666, all right? And then I end up with this number here. And you're like, this is an angle measure. This angle measure is not on 0 to 2 pi, but it is an angle measure where the slope of the line is -0.6 repeating. So let's think, where is that? All right, well, that's right here. See how theta, if you were to sketch a picture of the slope -0.588, here, if I go a negative angle, I rotate this way, and so that's this angle right here. But I only want answers from 0 to 2 pi, so I need to use this to figure out the alpha and the beta, and that'll be my final answers. Okay, so I'm going to, because what I got is not on 0 to 2 pi, like I don't want to call something -30 degrees, I would want to call it 330 if I'm on the interval from 0 to 2 pi. So that's why I don't like that angle measure. Okay, so now to find my alpha here, tangents are the easiest to work with because the answers repeat every single pi. So I can just add pi as many times as I want, and I keep getting angles that it's true for. So right here, if I am at -0.58 and I add pi, see how I'm at a half circle? By adding pi, and that's exactly where I want to be. So this alpha is going to be theta plus pi. I use my pi button, I use that beast of a decimal, and that's what I got. And then I've just gone from here to here, and now I want to keep going to here, but that's another half circle away. So I'm adding pi again, and then I'm going to end up with this one. The significance of both of these answers, when this rounds, 5 makes us 9 and 10, carry the 1, so this is going to be 5.70 because it said round to the 100th, and then this one is going to be 2.55. So the significance of these two answers, these are the angle measures, because we're in radians, not degrees. These are the angle measures where the slope of the line on that unit circle right here, the slope of this line is -0.6, the slope of this line is -0.6, and that happens at both of these angles. And hopefully these, they seem reasonable to you. This right here is 3.14, and this is just shy of that. And this is 6.28, and that is just shy of that.